Welcome listeners. Today we will discuss operators in Python. Rest portion. We have already discussed operators in Python. Few operators we will discuss in this lecture now. Basically, Python supports different types of operators which are as follows: arithmetic operators, comparison or relational operators, assignment operators, logical operators, unary operators, bitwise operators, membership operators, and identity operators. Now, bitwise operators. Now, bitwise operators operate on binary numbers. Python supports 6 type of bitwise operators, namely bitwise AND, bitwise OR, bitwise JOR, bitwise NOT, left shift, and right shift. Bitwise operators perform operation at the bit level. Now, bitwise operators cannot be applied to float or double variables. Now, bitwise AND, that is two operand you have taken, A and B, small a and small b. So A bitwise and B. Bitwise OR, that means A bitwise OR B. Bitwise XOR, that is A bitwise XOR B. Bitwise NOT, that means not A, left shift and right shift. Now here, for recap, we have given truth table for bitwise operators. We specifically give examples, that is truth table of A bitwise and B, A bitwise or B, A bitwise or B, and not A. Here, take one example. A equal to 5, its binary number is 0101. B equal to 3, its binary value is 0011. Now, we take A bitwise and B. Now, bitwise operator operates on at the bit level. That means column 1 for A is ANDed with, that is bitwise ANDed with column 1 of B. Same way for column 2, for column 3, and column 4. Now, 0 bitwise and 0 gives 0. 1 bitwise and 0 gives 0. 0 bitwise and 1 gives 0. 1 bitwise and 1 gives 1. So in binary, the result is 0001 and its decimal value is 1. Now, when we perform A bitwise or B, same way for column 1, A and B will be bitwise OR. For column 2, for column 3, and column 4, for both A and B, it will operates. That means 0 bitwise OR 0 gives 0, 1 bitwise OR 0 gives 1, 0 bitwise OR 1 gives 1, 1 bitwise OR 1 gives 1. So in binary, the final result is 0, 1, 1, 1, and its decimal value is 7. Now, A bitwise XOR B. So 0 bitwise XOR 0 gives 0, 1 bitwise XOR 0 gives 1, 0 bitwise XOR 1 gives 1, and 1 bitwise XOR 1 gives 0. So in binary, the final value is 0, 1, 1, 0. So in decimal, its final value is 6. Now in binary, we have taken A equal to 5. So in binary, 5 is 0, 0, 0, 0, 0, 1, 0, 1. We have taken 8-bit for clarity. Now bitwise NOT flips all bits, that is 1's complement. So 0 should be replaced by 1 and 1 should be replaced by 0 at bit level. So 0, 0, 0, 0 0 1 0 1 should be 1 1 1 1 1 0 1 0. Now in Python, integers are stored in 2's complement. So 1 1 1 1 1 0 1 0 is the 2's complement of -6. Now one quick rule is there. Not n equal to minus of n plus 1. Simply straightforward. So 5, not 5 means minus of 5 plus 1, that means -6. If you take 6, so not 6, not 6 equal to minus of 6 plus 1 equal to -7, like that. Now, in every left shift, every bit in A is shifted to the left by one place. Their most significant bit, that is MSB of A, is lost and LSB of A is set to 0. A equal to 5. So in binary, it is 0 1 0 1. Now, when we left shift, you see C4 is going to C3, C3 is going to C2, C2 is going to C1, C1 will be lost because this is MSB, and C4 position of final result is set to 0. So the final value is 1010, and in decimal it is 10. That's why A equal to 10. So A equal to 5, after one left shift, it will gives A equal to 10. Now in every right shift, every bit in A is shifted to the right by one place. Here least significant bit LSB of A is lost and MSB of A is set to 0. Same way, C1 is placed to C2, C2 is placed to C3, C3 is placed to C4, C4 will be lost, and C1 position of final result will set to 0. So A equal to 5, when right shifted, it gives 0 0 1 0. That means its decimal value is 2. So in computer, just you see A equal to 5, B equal to 3, print A bitwise and B gives 1, print A bitwise or B gives 7, print A bitwise or B gives 6, print not A gives -6, print A left shift 1 gives 10, and print A right shift 1 gives 2. Now, logical operators. Python supports 3 logical operators such as logical AND, logical OR, and logical NOT. And truth table of logical AND, OR, and NOT operators is exactly same with bitwise AND, OR, and NOT. Now, as for example, logical AND, just you see A greater than 0 and B greater than 0. Now, this expression will be true when A greater than 0 is true as well as B greater than 0 is true. Now logical OR, A greater than 0 or B greater than 0. This time either A greater than 0 or B greater than 0 or both A greater than 0 and B greater than 0 are true, then the total expression is true. Logical NOT, A greater than 0. If this is true, then NOT means false. If A greater than 0 is false, then NOT means true. Take one example. A equal to 5, B equal to 15. Now print A greater than 0 and B greater than 0. So 5 greater than 0, that is true, and 15 greater than 0, that is also true. When both are true, then true results. Now print A greater than 10 or B greater than 10. Now 5 greater than 10, false. But 15 greater than 10, that is true. For OR operation, if one is true, then true. So true results. Now A greater than 10 or B greater than 15. So 5 greater than 10, false, or 15 greater than 15, that is also false. When both are false, then false results. And print not a greater than 2. Now 5 greater than 2, that is true. So not true is false. Membership operators. Test for membership in a sequence. Python supports two types of membership operators, namely in and not in. These two operators test for membership in a sequence such as lists, tuples, and strings. The in operator returns true if a variable is found in the specified sequence and false otherwise. The not in operator returns true if a variable is not found in the specified sequence and false otherwise. Take one example. Operator is in, description is value found. Example, G in dog. Not in, description value not found. A not in goat. We take one example. Message equal to hello world. Now print H in message. This gives false because Python is case sensitive. So small h is not present in message. But when we print H in message, capital H, this time true results because capital H is present in message that is in hello world. Print Z not in message. Now Z, small z is not present in message that is in hello world. That's why true results. Print world in message, world is present in message that is in hello world. That's why true results. Identity operators, compare memory locations. Python supports two types of identity operators, namely is and is not. These two operators compare the memory locations of two objects. Is operator returns true if operands or values on both sides of the operator point to the same object and false otherwise. Is not operator returns true if operands or values on both sides of the operator does not point to the same object and false otherwise. So is description same object. Example is A is B. Is not same object. A is not B. Take one example. A equal to, that is a list example, 1, 2, 3, 4, and B equal to A and C equal to again 1, 2, 3, 4. Now print A is B. That is gives true, that is same object. Now print A is C. This time false results because different objects with same value. A and C having same value, but objects are different. That's why false results. But when we type print A equal to C, this time true results because values are equal. And print A is not C, this time different objects with different ID value. That's why true results. Thank you.